Alright, today we're going to talk about section 4.1 in our college algebra book on exponential functions. So first of all, just to show you what an exponential function looks like, you're going to have f of x equals a to the x. Now, when we refer to exponential, we're basically saying that that variable is going to be in the exponent. Okay, so a again is going to be your base number, which it's going to be greater than 0, and it's not going to equal 1, and x is going to be your exponent. Okay, so that's what an exponential is going to look like. So an example of something like that using numbers would be like 2 to the x. Okay, so you're going to see something like a number in this area with x as the exponent. So the first thing that they're going to ask you to do is they're going to ask you to evaluate them. So if I give you something like this, let's set 3 to the x, and they're going to say something like find f of 5. So what that means for you to do is it means for you to put 5 in for the exponent and then see what you get. So using your calculator, 3 to the 5th would be 243. Then again, if they give you something else like f of negative 2/3, again you're going to put negative 2/3 in for the exponent using your calculator. When you type that, you type 3 and then the caret symbol looks like that, and then for this particular one, depending on the age of your calculator, I would put negative 2/3 in parentheses just to make sure. If you've got the newer 84s that give you a little, I call it a little shadow box, if you put that, if it's in there, then you wouldn't need the parentheses necessarily, but it still would come out to be approximately 0.481 if you're rounding to 3 decimal places. I know it goes on a little bit further than that, but that's what it would be if you were to just evaluate. It just means plug the number in and see what you get. After that, they're going to ask you to graph them, which again, we'll use the same one. We'll use 3 to the x. And if I was graphing that, you can put this into your graphing calculator. You go y equals 3 caret x button and then hit graph. And you'll see something that does this, and this also depends on the age of your calculator and if you have a color screen or not too. With the new color screens that they have, they'll have this thing going on out here forever. It'll be right on top of the x-axis, and it will go on forever. It'll also cross through right there at 1, and the reason for that is because the rule, anything to the 0 power is always 1. And you'll actually see that. If you've got an 83 or a black and white screen, it looks like it just starts about here and then just goes up, and it's because it gets so close to that x-axis that you can't even tell the difference, because it's just so small and so above that no matter what you do, it's gonna look like it just overtakes the x-axis or just starts in the middle there, but really it goes on forever. They will ask you to write the domain, the range, and any asymptote. And an asymptote again is just a line that it cannot cross. So the domain for this is going to be all real numbers, and the reason for that is because no matter what you put in for x, you're going to get an answer out. There's no restriction on that. The range, though, however, is going to be from 0 to infinity. And notice we use parentheses there, not brackets, because it's not equal to 0. It rides along on top of 0 or right next to it, but never actually crosses it. And the asymptote is going to be y equals 0 because it is a horizontal line. So if you graphed a different one, I'm just going to change colors real quick, and I'll change to a red. And if I ask you to do, I can't circle out fx, we'll call it g of x, and let's say it equals 5 to the x. Now what's going to happen is that it's going to ride alongside the same thing. It's going to go through the same 0, 1, but then it's going to make a sharper turn. The reason for that is because when you put in numbers like 2, 3, 4, the higher the base, the sharper the turn, because what's going to happen is you're taking, you're comparing 3 squared to 5 squared. 3 squared is 9, 5 squared is 25. So instead of going up 9, you're actually going up 25 units. So it's a little bit sharper turn there. So the domain and the range and the asymptote is all the same. The difference is that you're just going to make a sharper turn. If you had something like, I'll make this in brown, we'll go h of x, and we'll go 1/3 to the x. Now you got a different story. It's a little bit different. It's kind of the flipped image of the 3 to the x. Now it's going to come down the hill. So if your base is a fraction, it's actually going to come down that, or have kind of a negative, or not a negative, but a downward slope to it. Still goes through the point 0, 1. Still has the same domain and range and asymptote, but this time, anytime you have a fraction, you're actually going to go downhill. Same thing with if I made a orange one that said, let's go to the x equals 1/5 to the x. Now I'm right in this category, and all I'm doing is I'm just flipping that 3 to the x and 5 to the x over the y-axis, and I'm getting the h and the t. So just so that you guys know that's what happens. So just to kind of give you a rundown on that is, if, I don't like that orange for you. If the base is greater than 1, so that's any of your whole numbers or your numbers that are higher, like 5 halves would be one of these, you're going to have a curve that goes like that. If you have, oops, I put an a there, just thinking ahead, a to the x, but this time it's from 0 to x, or to 1. That's basically just a fractional base is what that means, less than 1. Okay, now you're going to have ones that come down the hill like that. Alright, so if you have a whole number base, you're going to be like the one on the left. If you have a fractional base, you're going to be like the one on the right. Okay, then from there, they're going to ask you to sketch the graphs, but using stuff that we learned a long time ago in chapter 2, where they're going to give you something like this. It's going to say 1 plus 2 to the x. Now, if I'm looking at that, first thing that I identify is, I'm going to change the color back to blue. This is the base, that's my exponent, and now I've got a plus 1 sitting over here. And if you recall back from chapter 2, a plus 1 means I'm going to shift it up 1. Okay, so the whole thing is going to be up 1. I'm going to have the same kind of category or same type of curve that I had for 2 to the x. But this time, instead of going through 0, 1, it's actually going to go through 0, 2. And the reason for that is because we just said everything got shifted up 1. Instead of having the asymptote as the x-axis, this time the asymptote's going to be right here at 1, because again, we shifted everything up 1. So anytime I have an asymptote, I just make kind of a dotted line there, just as a reference so that I don't make it curve all the way down. And then 2 to the x looks something like that. And again, you can use your graphing calculator. You could type it in there and you'd see the same thing, or very similar to this. Domain is going to be, again, all real numbers. There's no restriction there, so therefore, no matter what, we can always put numbers in. The range, however, is now going to be from 1 to infinity because we shifted it up 1. The asymptote is again going to be y equals 1, again because everything got shifted up 1. Okay. Okay? This time, if you recall back from that chapter 2, that a negative on the outside reflects it over the x-axis. So just by drawing that or saying that out loud, we then have something that comes in here. Instead of being in, I'll just kind of drawing the parent, which would be something like that. Now, if I reflect it over the x-axis, it's still going to ride here, but it's going to ride on the bottom and then go down. Okay, so instead of crossing at 0, 1, this time it's going to cross at 0, negative 1, because again, it got reflected over the x-axis. Domain, still the same. There's no restriction. There's not an x we cannot put in there. The range, however, changed because we now go down to negative infinity and come up to 0 because it's going all the way down to the bottom. The asymptote is still the same as the parent. It's y equals 0 because we did not shift it up or down. The only time you're going to have a different asymptote on that is when you shift it up or down. It's not going to change it anywhere else like that. So as far as your shifting and stuff goes, that's all very similar to chapter 2. In this book particularly, 2.5, it was the section, I believe, that we did that all in. And the last thing that they're going to talk about in this particular section is going to be this formula. And this formula is for calculating your interest. Okay, that's a compound interest formula, and banks use it a lot of times for like your savings accounts. Okay, so things like that. So it actually has some value to it. P stands for principal, which principal is the amount of money that you're starting with in your account. R is the interest rate that you're going to be getting, and usually that's expressed as a percentage. So when they say that you're getting 4%, for instance, when you put that in, you got to put 0.04. N stands for the number of compounds. And just to kind of explain some of the words for that, if that says annually, that's 1 time. If it says quarterly, that's 4 times. Weekly, trying to think of all the ones that they'd use. 52. Monthly, 12, and perhaps just one more, daily, would be 365. Okay, so just so that you know. And then the T for that is time in years. Okay, so the things that they're going to actually be doing for you for this particular thing is they're going to give you basically everything that you need to know, and you have to just run the numbers through and basically be a number cruncher. And so their example that they use is something like this, where it says the sum of $1,000, so that's your principal, is invested at an interest rate of 12% per year. And if they're giving you something like 12%, please let me know, because I would like to make some money too. And it says find the amounts in the account after 3 years, so that's your time. Compounded annually. Semi-annually. Oh, I forgot that one. Semi-annually is twice a year. Quarterly, monthly, daily, all that kind of stuff. So if I put my numbers in, we've got 1,000 for my P. 1 plus the interest rate is 0.12. Now if I do annually, I'm going to divide it by 1, and then 1 goes up here also. So this particular number here and here, these two things are always going to be identical. Okay, so they're always the same. Alright, so one of the things that you can do with this problem now is you can do one of 2 options. One of them is you could type it all in your calculator, and if you're good at that, and if you're comfortable with your calculator, that works well. But one of the things that you could also do is you could do a technique I like to call chunking. And what that means is that you're going to do this basically in the order of operations. where this part would come first, then you would add the 1, then raise it to the power, and then times everything by 1,000. So if I did that, I'd take 0.12 divided by 1, which is 0.12, plus 1 to it, raise it to 1 times 3, which is 3, then times that by 1,000, and I get my answer of 1404 and 93 cents if you round it up. Okay, so again, basically what they're going to do is they're going to give you all those numbers, and then you have to plug it in and see what you get. The only thing that it might do is it might not necessarily change the annually, semi-annually, quarterly. It might just change the number of years. So that n might stay the same, but the years might change. So, but that's about it for section 1. Thank you.